Okay, let's dive into this. Welcome to today's Explainer, where we're going to do a complete microanalysis of, honestly, a pretty fascinating kitchen tool, the ultimate egg cracker. We're going to deconstruct the whole shebang, the design, the mechanics, and, yeah, the surprisingly dramatic aesthetic of this single device.
So I want you to just take a second and think about a universally frustrating and frankly messy experience. Manually separating an egg yolk from the egg white. I mean, we've all been there, right? You crack the shell on the edge of a bowl, you hold your breath, and you kind of carefully try to juggle that super fragile yolk back and forth between those jagged shell halves. And then, bam, disaster. A sharp edge punctures the yolk, it immediately bleeds into the white, and boom, your recipe is totally ruined. Not to mention, you've got this sticky, viscous mess all over your fingers and the counter. It's just an age-old problem that is completely rooted in human error. But what if engineering could just remove that mess entirely? Like, completely take human error out of the culinary equation. Challenge yourself to imagine a highly engineered, mechanical solution that's designed to completely eliminate the stress from this everyday kitchen task. What would it actually look like if its one and only job was to take the total chaos of a cracked egg and organize it into perfectly separated components? We're talking absolutely zero cross-contamination and zero mess on your hands.
Well, the cool thing is, we don't actually have to just imagine it. Look at this. This frozen moment in time represents the ultimate mechanical solution to this exact problem. It's a multi-tiered separation system that literally catches the egg mid-drop. So throughout this explainer, we're going to break this system down, moving top to bottom, to understand exactly how it achieves this absolutely perfect separation.
All right, let's start our spatial deconstruction right at the very top, with the catalyst zone. Because, before anything can be separated, the structural integrity of that eggshell has to be breached. But instead of just using blunt force, this device uses a really deliberate mechanical grip to get a perfectly clean break.
You can practically read the implied physics frozen right here. Here's how it works. Step 1, you squeeze the handles together. Step 2, that motion stretches the heavy-duty spring mechanism underneath, which creates a ton of tension. Step 3, the dark prongs push upward and the shell is breached. And finally, Step 4, gravity takes over, pulling those heavy liquid contents downward.
You know what's really interesting, though? Take a close look at the harsh, almost industrial aesthetic of this top component. Notice that heavy, coiled metal spring stretching across the bottom, and those dark, matte black handles gripping the brown shell. I mean, it kind of looks like a tool you'd find sitting in a mechanic's garage, not a baker's kitchen. It is entirely focused on delivering the raw, physical force needed to crack that shell cleanly.
Now, let's let our eyes travel downward to the middle section of the device. Because once that shell is cracked, gravity does its thing and pulls the contents down. But to safely isolate that perfectly intact yellow yolk from the white, a critical event has to happen right here, the filtration.
Right below the cracker, suspended in midair, is this smooth, brushed metal ring acting as a sieve. Just look at how securely it captures that bright, perfectly round yellow yolk right in the center. The diameter of this metal indentation is precisely engineered to cradle the yolk so it doesn't slip through. Meanwhile, the slippery, viscous egg white, which is way more fluid, just slides right through those open slots in the metal and cascades downwards in this clear stream.
What we're actually witnessing here is a totally textbook example of mechanical separation. If you need a refresher, mechanical separation is just the scientific process of using physical barriers, which in this case is the metal ring, along with natural forces like gravity, to divide a mixture into its constituent parts based on physical properties like size and viscosity. So this simple everyday kitchen gadget, it perfectly illustrates a foundational concept of physics.
Okay, let's keep moving down to the bottom third of the image to examine the final resting place of the egg white. Because, well, gravity has pulled that clear liquid right through the metal sieve, and it definitely needs a destination. And this brilliantly illustrates the final step. Directly beneath the falling egg white sits a stunningly elegant, clear glass bowl. Notice those delicate, gold-rimmed edges and that gorgeous floral texture radiating out from the center base? It is a highly refined receptacle, perfectly positioned to catch every single drop of the liquid white without spilling.
Now, if we take a step back and look at the whole system all at once, there's a really striking thematic contrast going on here. Up top, we have the industrial cracker. It's black, it's heavy, it's got visible metal springs, and it relies on this harsh mechanical grip. But down on the bottom, we have the elegant base, clear glass, a fragile gold rim, delicate floral texture. It's just fascinating how the designer combined the brutalist necessity of cracking a hard shell with the super delicate presentation of the final ingredient.
But hey, the engineering and the aesthetic contrasts aren't the only things happening here. We also need to shift our focus to how a device like this is actually marketed to a consumer. If you look closely, there's some cryptic, faintly visible text floating right there in the background.
It says in all capital letters, redefine. Take both hard and soft. I absolutely love this. It is beautifully melodramatic ad copy for an egg cracker. But honestly, it's also incredibly literal. The hard is obviously the brittle exterior shell managed by that heavy spring and grip, right? While the soft refers to the fragile yolk and the liquid white managed by the delicate metal sieve in the glass bowl.
You can see exactly where this text sits in the frame, just hovering quietly up there in the top right corner over the whole operation. It actively attempts to elevate a simple, functional kitchen gadget into like an almost philosophical tool. It's not just cracking an egg, guys, it's redefining how we handle the hard and soft elements of our culinary lives.
Okay, let's quickly summarize this highly efficient mechanical process we've just deconstructed. We started with one messy, unified object, the egg, and through pure engineering, its components are perfectly distributed. The hard shell, its final destination is safely trapped in the mechanical gripper up top. The soft yolk, caught and isolated right in the brushed metal sieve in the middle, and the liquid white, cleanly collected in the ornate glass bowl at the bottom. It is literal organization out of total chaos.
So, the crucial point is that this entire image, this whole egg separator system, is an absolute masterclass in where form perfectly meets function. Every single element, from the tension of the black spring, to the diameter of the metal ring, down to the width of the glass bowl, it's all perfectly calibrated to solve one specific age-old annoyance. And it does it while making the entire process look effortlessly beautiful.
Which leaves us with a pretty fascinating question to ponder. How many specialized gadgets does a modern kitchen truly need? I mean, when we see the intersection of messy, frustrating traditions and sleek, highly effective engineered design like this, it is really hard not to want one for every single task. I hope this deep dive has given you a brand new appreciation for the hidden engineering in everyday objects. Thanks so much for joining me in this explainer, and keep looking closely at the world around you.